Assalamu alaikum guys, my name is Mayer and I welcome you all to my channel. So today we are going to discuss one of the crucial topics in the general physics portion in O-level physics, that is momentum. So first thing first, we need to know the definition of momentum. So momentum is defined as the product of mass and velocity. It is defined as the product of mass and velocity. It is represented by the symbol capital P, and from its definition we can derive its formula, that is P equals to M into V, because product means multiply. Now if we talk about the SI unit of momentum, so SI unit of momentum is kg, meter per second, or Newton per second, and momentum is a vector quantity. Momentum is a vector quantity because its direction is same as velocity's direction. Now, if we talk about calculating momentum, let's assume there is a car which is initially at position number 1. Its mass is 10 kg. Sorry, it's traveling with a velocity of 20 meter per second. So now if we have to calculate the momentum of this car, we can simply multiply its mass with the velocity, 200 kg meter per second. Okay. The second thing is that two most important calculations in momentum. Calculations in momentum are: number one, change in momentum; and number two, total momentum. Okay, so let's discuss it one by one. If we talk about change in momentum, it can be classified into three different scenarios. First of all, if an object starts from rest, means its initial velocity u is equals to 0. Second scenario is that if an object continues to travel at same speed, sorry, in same direction, and lastly, the last scenario is if an object changes its direction. So Now, what do I mean with the change in momentum? The change in momentum is due to the change in velocity, that is delta v. Because if we look at the formula of momentum, m times c, mass always remains constant. It will never change. Whereas object's velocity can change, due to which we find change in momentum, and this change in momentum is named as impulse. So we are calculating impulse. Okay, let's discuss scenario number one. If an object starts from rest, if an object starts from rest, so let's say there is a car which is initially at rest, or stationary, its initial speed u velocity is 0 meter per second, and its mass is 10 kg. It starts to move in this direction, and after some time it gains a speed of 20 meter per second, or let's say 30 meter per second. Its mass will remain constant. Now we have to calculate change in momentum. So we can calculate change in momentum by using the formula change in momentum delta p equals to m into delta v. Okay, where mass will be 10 and change in velocity will be final velocity minus initial velocity. Now keep in mind, change in velocity is final velocity minus initial velocity if an object is traveling in same direction, continues to travel in the same direction. Travel in same direction. Whereas change in velocity will be final velocity plus initial velocity if an object changes direction. That is our scenario number 3. Now here change in velocity will be v minus u, that is 10 times 30 minus 0, and that will be finally change in momentum will be 300 kg meter per second. So this is our scenario number 1. Now let's move towards scenario number 2. Scenario number 2 states if an object continues to travel in the same direction, means it does not start from rest, it has some initial velocity as well. So now if we look, let's say we have the same car that is initially traveling at a speed of 5 meter per second. It has a mass of 10 kg and it's traveling in the same direction, and after some time it accelerates to uh, let's say 35 meter per second. Okay, its mass will be same as before. Now if we have to calculate change in momentum, we will write the formula change in delta p equals to m into delta v, m is 10, delta v will be v minus u, because the object is traveling in same direction just like case number 1, and it will be v minus u. V minus u is 35 minus 5. 300 kg meter per second. So now let's move towards scenario number 3. Let's say this is an horizontal surface, ground, and a ball with a mass of 5 kg. Sorry, that's a lot. With a mass of 2 kg is traveling towards this surface with a speed of 10 meter per second. After it collides with the surface, it rebounds and changes its direction. Its mass will be same and its velocity is 30 meter per second. Now if we have to calculate change in momentum, it will be m into delta v. Change in momentum will be, mass is 2, delta v will be v plus u. Since the object is changing direction, and it's a rule that if the object is changing direction, its change in velocity will be calculated by adding both the velocities. Delta p will be 2 into 10 plus 30. Delta p will be 2 into 40. Delta p will be 2 for the 8, 80 kg meter per second. Okay. So now we have discussed all the possible scenarios in which examiner can test you while giving the question on change in momentum. Now let's move towards our second scenario. That is total momentum. One important thing to keep in mind is that change in momentum will always be calculated of a single body. It will not be calculated of more than one body. Whereas total momentum will be calculated of two bodies, it cannot be calculated of one body. So, total momentum. Total momentum has a total of 4 scenarios. The first one is if one of the bodies is at rest. Second case is if bodies are traveling in same direction. Third case is if bodies are traveling in different directions. And last case is if bodies stick together. Okay. So let us discuss now if bodies travel in same direction. Okay. So scenario number one, if one of the body is at rest, let's say this is car A, it has a mass of 10 kg and it is traveling within a speed of 20 meter per second. And this is car B with a mass of 20 kg, with a mass of 8 kg, and it is at rest, which means its initial speed is 0 meter per second. Now, if we have to calculate total momentum, P total, total means adding up. So, in this scenario, we will add the momentum of A plus momentum of B. Momentum of A can be broken into mass times velocity, mass of A multiplied by velocity of A plus mass of B multiplied by velocity of B. Mass of A is 10, velocity of A is 20, plus mass of B is 8 and velocity of B is 0. So 10 times 20 is 200 and sorry, it will be 0. So total momentum will be 200 kg meter per second. So now you can see if one of the bodies is at rest, the total momentum will be the momentum of the moving body, as we can observe here. No, so now let's move towards second scenario, which states that if bodies are traveling in same direction, traveling in same direction. Let's say this is a car A with a mass of 10 kg and a speed of 20 meter per second. And this is car B with a mass of 8 kg and velocity 15, let's say 30 meter per second. So if we have to calculate total momentum will be equals to momentum of A plus momentum of B. Momentum of A will be mass of A multiplied by velocity of A plus momentum of B will be mass of B multiplied by velocity of B. Okay. Mass of A is 10, velocity of A is 20, mass of B is 8, velocity of B is 30, 10 times 20 is 200 and 8 times 30 is 24, 240. So 200 and 240. So total momentum will be equals to 440 kg meter per second. Okay. Now let's move towards scenario number 3. If bodies are traveling in different directions, this case can be divided into two sections. Either the bodies are approaching each other or they are moving far away from each other. Let's pick this case. Let's say this is a car A with a mass of 10 kg, which is traveling in this direction with a velocity of 30 meter per second. And this is car B, which is traveling in this direction with a velocity of 40 meter per second, and it has a mass of 8 kg. Hmm. Now, if we have to calculate total momentum, so keep in mind that it's a rule that whenever we have to calculate the total momentum and the bodies are traveling in different directions, their total momentum will be the difference between their momentum. Momentum of A minus momentum of B, that will be mass of A multiplied by velocity of A minus mass of B multiplied by velocity of B. Mass of A is 10 kg, velocity is 35 minus mass of B is 8 kg and velocity is 40. So 10 times 35 is 350 and 8 times 40 is 8 for the 32, 320. So 350 minus 320 is 30 kg meter per second, that is total momentum. This will be also be solved in the same similar way. Now let's move towards last scenario and then we will wrap up this topic by studying law of conservation of momentum. If bodies stick together, let's say this is a car A with a mass of 10 kg and a velocity of 20 meter per second. And while traveling, it sticks with car B, which has a mass of 8 kg and is, they both are now traveling at, let's say, 24 meter per second. So now total momentum, we do not have to calculate their separate momentum unlike in previous cases. Total momentum will be total mass multiplied by velocity combined. So total mass is 10 plus 8 and their combined velocity is, let's say, 30. 10 plus is 8 is 18 times 30. Now we can multiply here. Zero four five zero zero 3 0 0 3 0 4 540. So total momentum will be 540 kg meter per second. Thus, Okay, now we have discussed all the cases and now proceed towards the last subtopic of this area, that is law of conservation of momentum. Law of conservation of momentum. The law states total momentum of an isolated system remains conserved. Isolated system means that the system which is not affected by any of the external forces like friction, air resistance, gravity, conserved. Or we can also write that total momentum before collision is equals to total momentum after collision. Okay, so now we have discussed all the possible scenarios and the questions regarding the law of conservation of momentum. You can do it from your past papers as well. So now we will conclude here. Thank you so much. Allah Hafiz.